Welcome to Buildings and Beyond,
the podcast that explores how we can create a more sustainable built environment
by focusing on efficiency, accessibility, and health.
I'm Rob Aldrich.
And I'm Kelly Westby.
For this episode, I talked with Jesse Thompson, who's a principal at Kaplan Thompson Architects in Portland, Maine. I saw him present at a conference about a year ago. It was a great session called Stealth Passive House, or something along those lines. And the idea was people can be intimidated about passive house. They can hear about R100 roofs or very expensive windows. The certification can be complicated. So quite a few people are put off by it. But in a lot of his work in multifamily buildings, Jesse really integrates a lot of the core components of passive house into the projects, namely air sealing and ventilation. They're really fundamental to good buildings, and by incorporating these elements on the sly, as it were, a lot of his projects perform very near passive house levels. So it was a great conversation. I started out asking him about air sealing, but Jesse wanted to start with ventilation.
The last few years, I've felt like we were inside the home performance industry, or whatever we call this. There was this phrase that was rattling around called build tight and ventilate right. And we've gotten really sure over the last couple of years that we had that 100% backwards, that what we should have been saying is ventilate right, and then you can build tight. That we start with the fresh air, start with good ventilation, and then after you've got people happy and healthy inside a building, then you can get to work air sealing.
So what is good ventilation for these projects? What does it consist of usually?
It usually has a fully ducted heat recovery ventilation system, a box maybe on the roof, maybe at the end of the hallway, maybe inside each apartment, and that machine is bringing in fresh air and it's exhausting all of the pollutants from the kitchen and the bathroom, and it's capturing the heat. So the heat isn't leaving the apartment, but all the nasty stuff is. And there's always fresh air coming in and supplying it. It's a balanced system, always in a passive house.
Yeah.
And it always has heat recovery. And that heat recovery is way better than we thought we needed 10 or 15 years ago. It's at least over 80% of the heat recovery. It's a really good heat recovery device. They've
been around for a long time, for the 20 years that I've been in this, whatever industry we call this, like you said. And I have seen some repeated problems with getting systems installed, operated, and maintained to keep up with that. Even on day one, it's doubtful that a system has the performance you want without some tinkering or retro commissioning or something. Are you finding that these systems work, that contractors are getting used to them so that they do work more reliably? And I guess maintenance, I'll ask you about maintenance after that.
Yeah, I think this is the big challenge, is that the boxes are easy to buy, even though you always have to, there's some sort of pitched battle over buying a good enough box. But these are complicated things that weave their way through buildings that we may or may not be used to doing well. And I think that is one of the areas where we feel like Passive House and Energy Star have done incredible work at getting people to really test the systems and find out, were they really working or not. There's a lot of sort of faith-based construction in our industry where the game is to cover things up as fast as they can and move on to the next building. It's not to test to see if it's working and to really see. Most people are just trying to get on to the next one.
Yep.
So that's just industry endemic across the board, and then you combine it with a kind of system that maybe folks aren't quite as used to doing well. And then you have all these weird things, exhaust-only systems aside, like you talk to folks and you're starting to talk about a building and you're talking to, maybe it's a mechanical engineer you haven't worked with, maybe it's a contractor, and it's, okay, we're going to put the air in the middle of the living room, and then we need a heating coil to heat the air up because it's going to be cold coming in from outside. So we have to buy a heating coil, and then we have to pay attention to where we put it. And then we're going to dump it all in the living room and extract from the kitchen to save money. And so even then you get these systems that frankly probably don't work very well. And then you get someone who complains about it, and then the owner says, boy, I don't know why we did that. Let's stop doing that. Let's go back to the bath fan way. At least, we didn't get complaints there.
And what a big premium, what a big cost premium, installed cost of an ERV or HRV versus a bath fan.
So that's where I appreciate where the Passive House folks got much more rigorous, where they said, no, we will make sure there is fresh air into bedrooms. Like when the teenager's in there with their door shut, they're still getting fresh air. We're not going to put fresh air in the living room and pretend it magically somehow works its way into the bedroom where the person's in with their door shut. Like, no, we're going to put fresh air where people sleep. And you're just going to do that. You're not going to cheap out. And you're going to do such a good heat recovery box that you don't have to add a bunch of electric coils all through the buildings and add a bunch of cost. You don't need to do that kind of thinking. We're going to both make sure it really works and make it simpler. So those have been, I think, refreshing, and that they definitely take some pushing, though. But there's also this bizarre thing where I think multifamily buildings have these systems that never worked but are code legal. I think the bath fan exhaust system, it kept buildings from rotting out. It kept moisture out of bathrooms, but it by no means got fresh air to where people were.
Yeah. No, absolutely.
And so there's a funny thing where I think we have a code that prevents people from rotting out building but doesn't make people healthier. And there's a whole code path that's very inexpensive to do that's legal, but it doesn't work.
So, yeah, and that's, oh my God, there's a huge debate about that everywhere within our office. I mean, there are people in our office that are pushing strongly for mandating balanced ventilation in multifamily buildings. Mm-hmm. Balance doesn't necessarily mean heat recovery, but once you go to balanced, might as well push on to energy recovery. But my biggest hang up is I agree that bath fans, just exhaust only ventilation has some big potential problems, some big potential question marks. It's better than no ventilation often, maybe even usually, but as you say, there's no rigor in guaranteeing that fresh air gets to occupants.
Yeah, that funny thing where it's like, oh, well, we will build it just tight enough that code says we don't have to have balanced ventilation. And so we'll leave just enough holes. I mean, no one is putting the holes where the people are, first of all, and there's no pretending that it works. And then, this is a funny thing where, the Passive House folks have this reputation for crazy air sealing. And when I go around every American city, I see peel and stick membranes on every building. I see, Blueskin and Carlisle products on everywhere. So people are building incredibly airtight buildings everywhere.
Way more. Yeah. Way more.
Just the building products are so different than we were doing 20 years ago. So that to me is a little wacky where we're still pretending that those buildings are not airtight when I'm looking at those products saying they're an inch away from being a passive house. They just haven't thought it through. And they don't know where the air's coming from, the parking garage and the elevator shaft. It's just not,
So I totally agree. Exhaust only doesn't work. You can make the argument exhaust only.
It doesn't work to make people happy. It keeps the buildings from rotting, I think. It's successful at that part.
But are you finding that your ERVs or HRVs are working? Are they installed, commissioned? Yeah. That's my hang up because I see bad installations so often. And then lack of maintenance. These systems require more maintenance than exhaust only.
Well, that's the hard thing is we're in one of those step changes where we're making our buildings perform a lot better and they're getting more complicated at the same time. And we've done this before. Like we do these moments when we go from a 2x4 wall to an engineered system, or we start rain screening, or all the other things that we've done in buildings that make them work better. But sure, they're more complicated, and it's hard. You do have to put a bunch of effort in when you're at that transition point, and you have to figure out what to push on, and that's kind of grinding work. Making sure someone made their fresh air system work. Like that's.
I think that's important.
That's not very glamorous.
But you're finding that they are succeeding.
After people put a lot of effort into them. I mean, our very first passive house building, we couldn't get certified for. I think it took a while because one kitchen exhaust louver, the duct wasn't connected to the grill, and it just took so long to hunt it down. Like, it took multiple testing. It took a person getting access to an apartment to go look in to realize that, oh, that thing isn't connected to that thing. And we didn't get certified for quite a long time because of one kitchen in a 45-unit building. So, but if the client hadn't tried to be passive house, it never would have gotten found.
Yep, right.
No one ever would have fixed that kitchen.
Yep. Yeah, no ventilation from that kitchen at all, right.
And then, it's like it was incredibly hard to get it there, but we got it there, and that took rigor.
Yeah. That's something that I've been involved in, is just measuring the performance of systems when they're installed, and especially new systems, especially if it's new to the contractor, new to the builder, new to the developer, there's a learning curve with all of it for everybody. So
no, I mean, building industry is a really strange industry where our quality control standards are, compared to the automotive industry or any product industry where they make thousands of the same thing, they have quality control that is rigorous, that checks everything, and that has a way of chasing out flaws. And here we are in this weird business where every single one we do is different. Every building's a prototype, and we don't have rigorous quality control standards, quite frankly.
So for you,
it's coming, but it's.
I mean, for you, are you in your projects? Are you getting to a point where every building is not a prototype? That there's enough, I don't want to say standardization, but similar systems that it's getting easier.
I think that is really you're getting back to the talk you saw about the stealth passive house, and that's what we were really talking about. Is that so? Here we are. We're architects. We aren't building scientists. We aren't researchers. We aren't. We aren't on that field. We're trying to design beautiful buildings that our clients love, and then we got into this trying to make better buildings technically. And I would say yes, on the multifamily buildings, we tried out a bunch of things 4 or 5 years ago, and we've settled into, for buildings of a certain scale, a thing that kind of works. And it has quieted down where we're starting to draw the same wall every time. We're starting to think the ventilation systems are probably pretty similar, and it's allowed us to focus on architecture a little bit more. Again, because we maybe are a little bit over that technical hump where we can, it is funny. We can look at a building if it's in the 2 to 4 stories tall wood frame, 4 to 5 stories tall, in the Northeast. We're like, we can make that. We can get that to a passive house. Throw a 6, 8, 10-story building at us, and we'll be pretty lost. We aren't big city architects.
Gotcha.
But if you're in wood frame, 5 stories max, I could probably rattle off the 5 things we need to do to make a building a passive house.
Could you rattle off the 5 things you need to do to make a building a passive house?
Yeah. So there you go. Right, there's a test. In the Northeast, we build out of wood. We are probably a 2x6 wall with exterior insulation that's about 2 to 3 inches thick. There is probably a roof that's about, R40 to 50. We are stringently air sealed. We have a heat recovery ventilation system that is either on the roof or at the end of the hallways that's doing a block of 10 to 15 apartments in one unit. And it's got at least 80% heat recovery on it. Triple glazed windows, probably if we're in affordable housing, it's fiberglass or vinyl. If it's in a nicer building, it's a nicer triple glazed window. I would say that's that right there gets us 85, 90% of the way.
Okay.
If you're in a peculiar orientation where you're all facing west, and we're starting to look really carefully at air conditioning issues. That one is really a tricky one.
I was going to ask you about heating and cooling. Is there a standard for that, for this kind of typology, building typology?
Well, if you're doing a really, really good building, I think one of the things that's been so funny for us is, these intricate technical programs like Passive House are hard to kind of get your arms around. And one of the ways I think that was really, really effective for us was I went back to kind of some of the first stuff I ever learned, and they said, oh, passive house, it's a heating load of 1 watt per square foot. And that kind of stuck for me. I was like, okay, wait, all right, I get this. Like a bedroom is a 10 by 10 in affordable housing, 100 square feet. So a 100 watt light bulb heats a bedroom on the worst day of the year. Okay, I can get my head around that. Like,
Yeah.
you've got a 600 square foot apartment and you need 600 watts of heat. Yeah, okay, that's like that little portable heater they use on construction sites, like, or you might use in your attic. Like, oh, 600 watt heater. I get it. Like, that's the heating system for that apartment. And that was kind of this radical thing of what's the thing that can keep an apartment warm. And that gets you down to this funny realization that you can do it with electric resistance. Electric baseboard like they did in the Pacific Northwest works pretty awesome in a passive house.
Yep.
And it's super simple and has a thermostat, but it doesn't air condition your building. But that's the territory you're in. It's just this crazy jump down. But that was funny for me, was having this thing stuck in my head of, oh, it should be about 1 watt per square foot. Like, I can talk to a mechanical engineer about that. I'm not a mechanical engineer. I'm just an architect. But I can, ask them, are we close to that? And they should be able to give me that number.
Yep.
Oh, no, we're at 10. Oh, when we're not anywhere close, are we? What are you thinking it is? Yeah. That sort of plain talk has been part of it, of like, oh, these buildings should be 1 watt per square foot, which is radically tiny. I mean, it's just this minuscule amount of heat.
Yeah, it's a big game changer. It really is. But
It's just so tiny, it's hard to wrap your head around.
I agree. And we've seen, we've had success with really very efficient buildings without needing to distribute heat. A point source heater in a central space. You turn on a light in a bedroom and somebody the gains from a person being in the bedroom heats the bedroom. It is a game changer.
And so that takes you to air conditioning.
Exactly.
Okay, so if you can heat a building with a 100 watt light bulb, boy, it must not be that too hard to overheat it, is it?
Exactly.
Huh.
Exactly.
Point that window towards the sunset on August and you could probably get kind of hot in there, even in Maine or northern Vermont.
Right. Yeah, so even in Maine, you must be seeing more need for air conditioning in passive house.
Yeah, and I guess, of course, it's not just passive house. Everybody's got air conditioners now, right?
Okay.
All my neighbors have air conditioners, even in Maine now, and they didn't in the 70s. So that's just changed across the board, where people's expectations are different, I think, than they used to be. But in apartment buildings in Maine, with the worry that summers are going to get even hotter coming up, yeah, I think we need to be planning for air conditioning in every apartment building.
And are you still, even affordable housing where that has not been standard, are they coming to a realization that maybe they need to?
They very much want to. There are pretty severe budget limits in our state that we're still going without. But I think if you talk to any affordable housing developer in northern New England and ask them, this has nothing to do with passive house, just on your new buildings, are you running into overheating issues on any of your new buildings? And they will probably nod and say, yeah, we've had some real struggles, like high humidity, are you seeing it? This isn't a passive house thing. This is just a new building thing in northern New England. And
yeah, right.
people are getting overheating in their apartment buildings.
Yep. And so Are you going to heat pumps? Are you doing, I've even seen some projects with window air conditioners. That are borderline passive house? How are you?
We're definitely trying to do heat pumps because they're so much better. They use so much less electricity than electric resistance. We are a pretty frugal state. People are being asked to build buildings in the $160 to $170 a square foot range for affordable housing, and in today's, that's pretty tough to build anything for that cost in our area.
Yeah.
But that's the target the state agencies are asking people to work for. So there are just these huge budget challenges in 2019 building anything. But so that aside, heat pumps and definitely, and then we've got these engineers we work with who are pushing us really, really hard to go back to hydronics, and that's a sort of a really, to go back to hot and cold water loops instead of heat pumps, which is kind of interesting.
Have you? Well, what are the reasons?
Their reasons are interesting. One of their main reasons is they say, so the refrigerant, whatever we're using now, and I don't know what refrigerant we use now, they say we've been through like 3 refrigerant changes in the last 30 years, and we're probably got another one. So, owner, you're going to put a thing in your building where all the stuff that makes it work is going to be obsolete and probably illegal in another 10 years. So there's a little bit of a planned obsolescence.
Yep.
They are also pushing us that they're saying, these heat pumps might only be a 20-year lifespan. That they just aren't expected to last very long as pieces of machinery. And when you have a 40-unit building and you've got a whole lot of these machines,
Okay.
That can get pretty complicated, and it's hard to downsize them far enough still. And refrigerant leakage, they sort of rattle off these reasons. And they're pushing us to go back to these sort of very, very simple fan coil systems of a hot water loop and a cold water loop, because they're saying, okay, so you change the box on the outside of the building, but you only change one of them. And if it fails in 20 years, you put a new magic, super efficient thing that didn't exist when you designed the building, but it's still water running through the building. It's future-proof is what they say. So that's been kind of an interesting push.
We're seeing that too. And there's no silver bullet. I mean, heat pumps can work great. I have tested many. I've tested many that have not. I've tested many that have worked great. The durability, the long-term viability, the refrigerant phase out, the refrigerant leakage, those are all big question marks that I don't know that anybody has a perfect answer to. But
Yeah.
as far as first cost for heating and cooling with a single system, it seems with modest in buildings with very modest loads, it seems like that would be appealing. Is that accurate? Or clients?
Yeah, and I think the clients, I think, are pretty happy to have someone who seems to know what they're doing pushing for something. And I think they do have, most people have hot water baseboard buildings that seem to work pretty well.
Yep.
They may not love the cost they get out of them, but they don't think of them as failing,
Yeah, okay.
the buildings they own
Yeah.
in our area. And yes, a lot of clients want to not be using fossil fuels, and they probably, okay, I guess there's a gas system running that, and that's not great. But
Well, for now,
I think it's for now, right? Yeah,
that plant might be able to be replaced with a much more efficient, lower carbon emission device.
yeah, easier than retrofitting a 40-unit building and ripping out all the heat pumps.
This is true. This is true. It's not crazy.
So yeah, we've got a building right now that's a 65-unit building, and we are looking at electric resistance heat and a cooling loop that runs through the whole building, and it's only going to air condition the living spaces. It's not going to air condition the bedrooms. That's how we're going to keep costs down, and we're going to have one little tiny fan coil in the living room of every apartment. So it's affordable housing, and
Okay.
so your living room will be nice and cool. And if it's a really hot night, you're going to keep your bedroom doors open.
Turn on a fan.
And and I think we're looking at it seems to be like it's like $320. It's like $5,000 a unit to get this system into the whole building, and it's definitely cheaper than a VRF fancy computer-controlled commercial heat pump system.
Yep. Yeah, and so there's a central chiller. Is that
A central chiller,
Okay,
yeah. So
yeah. Totally viable? It's frustrating to have loads that are so small and still struggle to find really simple.
Well, that's the other thing our engineers love is like when you only need a tiny bit of heating and cooling, a water system can deliver a tiny little bit of heating and cooling.
Yeah, right. This is true.
It can infinitely small. It can just keep going. And so that's so I've been like, they're persuasive folks, and okay, we'll try it.
Yep.
But yeah, I mean, it is. Yeah, you're right, because it is this funny thing where you end up in these bizarre little rabbit hole conversations. The great thing is that we're just seeing that if you can pull off these passive house buildings, they're just so incredibly economical to run.
Yeah.
The first one we did, we have measured numbers, and it's like $60 per apartment per month. Heating, cooling, hot water, and absolutely everything. All electric bills, like every single bit of energy. $60 a month to run an apartment. That's amazing.
Nice. So happy clients and
very happy clients, and it's and they also say is that the costs are much closer to the modeled expectation than all the LEED buildings and all of the other like performance programs they try. They're saying it, these passive house buildings are running closer to what the fancy design teams told them it might be than any other system they've tried.
Interesting.
Much less variance,
Okay.
which I think is interesting. Which gets back to that testing, that like it's about the only program that forces you to test the damn building and find out if it worked or not. And then if it triggers Energy Star, so you have to do all the Energy stuff. Well, the Energy Star stuff is the great stuff.
So the Energy Star for homes with the kind of the quality control throughout the construction design and construction process.
Yeah, somebody like looking at the insulation, looking at the building, and staring at every wall. That's the great testing.
Yeah. So
that's where owners get so much money out of that, so much value out of that for the money they spend.
And they appreciate that.
I hope so, because it sure is about the biggest bang for the buck they're getting.
I mean, do the owners see that, or are they kind of a little bit divorced from that whole process where insulators are being called out or air sealers are being called out about something?
I mean, they're definitely getting these memos that are usually saying like, "Hey, somebody didn't do something right and we caught it."
Okay,
you got to appreciate that.
Yeah. That's cool.
I hope so.
That's cool. Yeah, ratings are a lot of our clients. We do a lot of ratings, and we have some people are only in it for the incentive. There's utility incentive, so I have to hire a rater. It's like they're not happy. But then we have some clients, repeat clients, who really do see the value in that layer of quality control that they wouldn't be getting otherwise. I mean, building inspectors, they can't get into that level of detail. The code doesn't get into that level of detail. So
no.
Yeah, pretty good.
Yeah, it's really interesting. And so I think there is that piece of it's been a funny journey over the last years, but we are definitely to the point where we're starting to work on a lot of buildings all over. So we managed to have a success early on in Maine with a sort of a passive house building that was a decent scale, and now we've got calls from New Hampshire and Connecticut and Massachusetts and Maine, and we're doing projects all over, and a lot of it is being driven by affordable housing and state agencies saying, we will score projects well in our competitive rounds that pledge to make a passive house, and so we've got folks calling us. So it's pretty great because it's seeing a lot of great better buildings getting built really quickly.
Excellent. So is really most of your business high performance, if not certified, going in that direction?
Yeah, it is absolutely. I think our business is, I would say it's half single family homes, new and renovation, then another chunk of multifamily. The multifamily is not the biggest thing we do. I'd really say it's homes for people.
Okay.
Is the biggest thing we do. We also do a bunch of restaurant work, and the restaurant, high performance restaurant work that's a weird one. Yeah, so it is everything we're doing is high performance. I think we have pledged to the AIA's climate change goals, and we've signed on that this idea that everything we do will be carbon neutral by 2030, which is a little scary because that's only 11 years away. But I think we were looking at, we actually measure every project we do, and we check it against the targets. And last year, I think we had on average 70% reduction over sort of the American baseline on projects across the board. So we're definitely getting some kind of amazing successes, I think, by this focus.
That's a pretty cool statistic right there. That's awesome.
And admittedly, we don't tackle the super hard things like college laboratories.
Yeah.
Those are these crazily hospitals, things that are crazily energy intensive. But little old us we've definitely figured some things out. I think it feels like, and trying to spread the word.
Yeah, absolutely. And your single family clients also, or do they come to you because they want high performance?
Well, it's definitely something that we tell people we do.
Okay.
And our tagline is beautiful, sustainable, attainable. So it's
good.
I'm sure we are definitely attracting folks who are looking for it. But yeah, I think to us, every house we do should be able to be net zero. if it isn't, we must be doing something wrong. Kind
cool.
of thinking.
Cool.
Is it? And honestly, the single family houses, I guess we were talking a minute ago, multifamily is still in this really huge learning curve moment, it feels like, where a lot of people are trying a lot of things. And I hope in 10 years we look back and it'll be a solved problem. To us, the single family is kind of looking like a bit of a solved problem. Like, it's not particularly hard to make a net zero home.
Right.
You had a heat pump water heater, some air source heat pumps, make the walls R30 to R40 and air seal it well, and you've probably got a net zero home. Like, it's net zero energy just isn't very hard with single family homes. Solving the transportation, there's plenty of other hard things about it, but that part should be pretty easy.
Yeah. Yeah, I agree. The single family new construction is one of the easiest things to
But 15 years ago it wasn't. I mean, there's people who were trying all sorts of stuff, and it was a complete head scratcher. But in 2019, it's like, when I'm out in the world talking or something, and someone starts asking about what wall assembly are you using, and it's like, look, it's 2019. If you can't Google 5 high performance wall systems, you're not trying. You don't need me to tell you what wall to do here.
Yep.
Just Google it.
Yep.
This is a solved problem.
That's cool. That's cool to hear that we've gotten there. I mean, I don't hear that enough, but I agree. It's becoming more and more well understood, more and more. You look at details, you look at sections, you see the air sealing. I mean, that's part of sets now. I mean, people know that they have to pay attention to that stuff.
Go do what Building Science Corp says to do.
Very good.
Okay.
Very good.
Oh, you don't want to use foam? Okay, go do what the other people say to do. Okay. There's lots of resources out there in single family world, but the multifamily is complicated. You have lots of different users with crazily different needs. You have urban sites, you have bigger scale, you've got different machinery, and in a really tough cost environment. So it's not quite a solved problem yet, but it feels like we're getting closer.
Yeah, you feel like you guys have your own method for a specific building type, but industry-wide, you're not seeing that become standardized.
No, I don't think so. And I guess that's why the Stealth Passive House talk, I felt like we were really trying to push people on a couple key things that were really eye-opening for us. And one was that we've really been working hard to reverse this idea that Passive House is about really thick insulation. and that's why we're so focused on really get the ventilation right, and then work on the air sealing. And honestly, you've probably done 70% of the heavy lifting at that point.
Right.
And when we were doing these energy models and we first saw it and we were sort of turning all these dials, it was kind of this amazing thing that it was like the insulation wasn't doing the work. And I was like, I didn't really get it at first. And then I was sitting with the mechanical engineer and I said, okay, wait, so you've got 50 cubic feet per minute in an apartment is the ventilation rate. So you've got 50 cubic feet coming in, 50 cubic feet coming out. You've got a 40-unit building. Okay, yeah. So you have 2,000 cubic feet of air moving 24 hours a day, 100% of the time. I was like, oh, okay. That sounds like a lot of air. They're like, yeah, that's a lot of air. This is a tornado blowing through the building 24 hours a day. Yeah. And then we first did these buildings, we stood next to the machine that was moving the air. It's like, wow, that machine's working really hard. You're right, there is a lot of air moving through this building. It was and then it was this idea that apartment buildings have a lot of people living in close proximity, and there's a lot of air moving through there to keep the building fresh and healthy. And there's a wind blowing through the building. So if you have a really good heat recovery box, you are absolutely doing the right thing just because of the quantity of air moving. That's the biggest driving force. And that's why you have to have really, really good heat recovery stuff.
Yeah. Infiltration and ventilation, certainly the biggest pieces. And
after that, make sure you don't do dumb things like connect steel from the inside to the outside. Make sure you're totally thermally broken with at least, R10 to R15 to R20. And you're probably getting there. And the other funny thing that we realized is that every project team is just used to fighting over insulation. It's just this classic thing you do. You design the building, it's over budget, You take all the insulation off the building.
Oh, God.
And it's this ritual dance where like the contractor knows that you do that first and everybody's used to it. And so we were kind of realizing that you can't do that with air sealing. You can't look at the owner and say, we need to air seal it a lot less. We're going to save you money. Because, then you look at them and you say, well, okay, so how much money and how much less better are you going to make it?
Yep. That's
or if they say like, oh, all that air sealing is going to cost a lot extra. Well, what do I get for free?
That's interesting. Yeah,
they don't always have a good answer about what they get for free, because most people can't quantify it.
That's interesting. Yeah.
So you get this very different cost reduction question if someone says like, oh, well, that passive house air sealing is really expensive. It's like, okay, well then give us only half passive house.
What is that, Jesse?
Yeah, exactly. Yeah, like they don't know either. So it's been a different thing where everybody knows how to take triple glazed windows out of a project. Everyone knows how to take half the insulation off a building.
Yeah.
It's like everybody's good at that. So when you can do these buildings that have code levels of insulation, there's nothing left to take.
Right. Yeah, and I've seen it, code levels of insulation with the rigorous air sealing and the excellent ventilation get you to passive house levels, yeah.
Especially the bigger the building gets.
Right.
The bigger the building,
Right.
the more the forces are going in that direction. So, yeah, it's been really interesting for us. It's been taking the focus off, and that's what I have been going, if I'm talking to folks about one thing, it's this. It's like your ventilation equipment that your engineer's doing is probably nowhere near good enough. Like you really need really good stuff so that the folks aren't freezing in their bedrooms when this 50%, again, someone explained to me. So if you buy a 50% effective ventilation unit and it's 0 out and 70 inside, the air coming into your bedroom is 35 degrees.
Right.
Oh yeah, that's pretty cold.
Yeah.
Like I don't want to be 50% of the way to 0. But if you're 85% efficient, that air coming in the bedroom is 60. Oh, 60, that sounds a lot better. Yeah, right.
That's cool.
It's a lot better. And those kind of levers are things that are really worth working on, that because if you stop at 50 and you do that standard stuff, you don't get the benefits.
Yeah. That's good. You've learned the buttons to push a little bit too.
Yeah. I mean, half of it is, are these funny little like tidbits you just put in meetings.
Nice. Excellent.
I do think the big thing that's going to change is when people start asking for great ventilation systems in their apartments. So when condo buyers start asking about like, oh, so what kind of ventilation system does this apartment have? That's when the market turns inside condominiums, when people really start asking. And I think it's when people become really attuned about asthma in urban environments with their kids. And, that sort of health consciousness is what's going to really change another piece of construction in America, is when homeowners, and, that's what I really would tell to every homeowner who's even thinking about buying a house or a condo, like, oh, what's going to get me fresh air in the bedrooms when my kids are sleeping? And is it going to be filtered?
I'm not arguing that would be really a sea change, but are you even starting to see that? I'm not sure that we see that in any scale.
No, I don't think we're there yet, but I think it's coming pretty soon, because we had a building recently, and it was a condominium project, so the realtor was in the building, and the team was really struggling. They were like, why do you keep saying we need to have this ventilation system? They basically looked at us and they said, no one else in town is doing this. Why do you say we have to do this? And you say things like, because it will work, and the other thing they're doing doesn't work. They really didn't like that answer, because they were selling the other thing.
Yeah.
And finally, the realtor did say, she's like, a lot of these buyers are really health conscious. She's like, I think I can sell that. I can tell people that there's a feature that you have fresh filtered air in all the rooms of your apartment, and I think people will buy this over the other thing.
So she came around just in one kind of meeting with you?
Oh no, it wasn't one. It was like 6. But
okay, all right.
It was 6 of us trying every single trick we had to try to convince them to do it.
Okay.
But that was the one where she finally said, like, yeah, that I can do.
Okay.
That will bring people around. Because she just had 2 young kids, and she was thinking about it. And I bet she was thinking about her own house all of a sudden.
Yeah.
So but it is person by person. Yes, a giant marketing campaign would be wonderful.
Yeah. That'll be a big step.
by the American Fresh Air Society or someone.
So do you think that's it? Do you think I usually wrap up with like asking, what are we going to see 5 years down the road? But you already started us on this line of conversation. Do you think that that we're going to see more high performance as far as efficiency, as far as sustainability, as far as carbon emissions being driven by health concerns on the residential side? Is that?
Boy, I don't know, because I'm no sort of trend master or anything like that. I do know that all the health stuff sweeps through everybody, like gluten-free sweeps through the country. And,
Okay.
These things do catch fire. I think the work in the affordable housing community and the take-up of passive house is really amazing, and it seems to be happening really quickly, it's changing an industry really fast, and I think we'll get some really good buildings coming out of the next 5 to 10 years in that sector. And then I think other building owners, I think university dormitories are happening pretty quickly. They're jumping on it as well.
Yeah.
People who own buildings a long time are hearing there's a thing out there that seems to be working pretty well.
Nice.
So that group of folks, I think, is catching on pretty quick.
Cool.
Yeah.
Cool. Thank you, Jesse. Thanks very much.
You bet. Thanks, Rob.
If you want to hear more from Jesse on this, and you can make it to Portland, Maine later in October, Jesse's going to be talking at the IAQ and Energy Conference on October 31st, Halloween 2019. I've been to that conference several times, and it's a really good conference. I will probably be there. There's a link on our website, or you can go to iaqandenergy.com. Everything's spelled out, A-N-D spelled out. Also, if there are any multifamily ventilation geeks listening, there's a proposed amendment to ASHRAE Standard 62.2. That's the standard that deals with residential ventilation. And this amendment would limit where exhaust-only ventilation could be used in multifamily buildings. The idea is this would get more fresh air getting to dwelling spaces more consistently. That amendment is open for comment until October 21st, I believe, 2019. We'll put a link on our website, or you can find more details on ashrae.org. Thanks.
Thank you for listening to Buildings and Beyond. For more information about the topics discussed today, visit www.swinter.com/podcast and check out the episode's show notes. Buildings and Beyond is brought to you by Stephen Winter Associates. We provide energy, green building, and accessibility consulting services to improve the built environment. Our professionals have led the way since 1972 in the development of best practices to achieve high-performance buildings. Our production team for today's episode includes Dylan Martello, Alex Mirable, and myself, Heather Breslin. Thank you for listening, and we'll see you next week.